Hello, my dear students. This is Amines chapter lecture number 2. We are going to discuss preparation of amines. This is Ellen brand of chemistry. So please subscribe Ellen brand of chemistry for going updates and for the another chapters. So look at now we are going to prepare amines. In the previous lecture, some of the preparation methods we are seen, and each and every preparation method, even applications also we are seen, right? So now some other preparation methods such as from azide, how can you prepare amine? From oxime, how can you prepare? From isonitrile and imines, how can you prepare amines, that we have to see. That is first one, azide. From azides, how can you prepare? From azides, how can you prepare? Azides, how can you prepare? Then after, from the azides, how can you prepare amines, that we have to see. From azides. So azides can be converted into amines in the presence of reagents such as one is lithium aluminum hydride, second one hydrogen in the presence of nickel or platinum or palladium. These two reagents, azide can be converted into amines. Look at, for example, one of the compound we are taking, that is pH, then CH2, bond CH2, bond Br is there. When it is treated with sodium azide NaN3, then in the presence of ethyl alcohol Ce2H5OH, then it will be converted into pH, then CH2, bond CH2, bond N3. Here Na and Br both will be eliminated. Sir, C2H5OH act as a solvent in this reaction. Sir, NaBr will be eliminated. Okay. When azide will be formed, so this azide can be reduced in the presence of lithium aluminum hydride, or even if you take hydrogen in the presence of nickel or platinum or palladium. So look at that, can be converted into CH2 bond NH2. So like this will be formed. So azides can be converted into any azide. So like this N3 will be there, azide. That will be converted into in the presence of lithium aluminum hydride. This N3 group can be converted into NH2 group. That you have to remember for the preparation of amines from azides. So next one, oximes. From the oximes, how can you prepare? From oxime, one more method, from oxide. All these methods are generally out of NCERT textbook. So, but in the JEE mains examination and JEE advanced examination, even these problems also they are asking. So you have to remember that. From oximes. So oximes, how it will be formed? Oximes? Oximes generally, aldehydes are ketones. When it is reaction with hydroxylamine, oximes will be formed. For example, CH3, then C double bond O, H will be there. This is we are calling acetaldehyde. Acetaldehyde, when it is reaction with a hydroxylamine, NH2OH, hydroxylamine. Then H2O will be last from this. H2O will be last. Then oxime, C double bond N bond OH. Of course, lone pair of electrons are there on it. Then CH3, then H, like this will be there. So this is we are calling oxime. Sir, oxime, when it is treated with lithium aluminum hydride, this NOH group can be converted into NH2. So how it is? Then CH3, bond CH2, bond NH2, like this will be formed. Clear? So oximes can be reduced by lithium aluminum hydride. So one more oxime we are taking for example, cyclohexanone we are taken. So that is cyclohexanone. When it is reaction with a hydroxylamine NH2OH, so this will be escape out, H2O will be escape out from it. What is this? Cyclohexanone. So here cyclohexanone, when it is last H2O molecule, then oxime will be formed. Oxime, how it will be? Look at. Sir, here double bond N bond OH will be there. This oxime group, C double bond O NH group, can be converted into, in the presence of lithium aluminum hydride, that will be converted into, that is cyclohexane attached with NH2 group. Amine will be formed. So this is from the oxime. Next, one more method is there from isonitriles. From isonitrile we can prepare secondary amines. Secondary amines we can prepare. We cannot prepare the primary amines from the isonitriles. Look at, that is third one, from isonitrile. From isonitrile what happens? Alkyl isocyanides. This only we are calling isonitriles. Alkyl isocyanides can reduce in the presence of lithium aluminum hydride, or followed by H2 in the presence of nickel. So that will be converted. For example, CH3 bond NC, N triple bond C, that is isonitrile we call. Sir, in the lithium aluminum hydride, that will be converted into CH3 bond NH bond CH3. This is we are calling the secondary amine. Secondary amine will be formed when isonitriles are reduced. But in case if you take cyanides, nothing but nitriles, that can form only primary amines. This can form secondary amines. Right, one more example. For example, benzene isonitrile will be there. Carbyl amine we call benzene isonitrile. NC will be there. In the presence of lithium aluminum hydride, what happens? Then benzene as usual. Then NH bond CH3 will be formed. Sorry, N-methyl benzenamine. N-methyl benzenamine or aniline. Benzenamine will be formed. N-methyl benzenamine will be formed. From isonitrile it happens like this. The last one, from the imines reaction takes place. From the imines also we can prepare what? Amines. How can you prepare amines? From the imines. So actually imines, how can you prepare? So aldehydes and ketones from imines. Imines, how can you prepare? For example, CH3, then C double bond O, H, acetaldehyde. When it is treated with ammonia, that is NH3. Now even here H2O will be eliminated from this. Then CH, double bond NH, then bond CH3. This is imine. Imine will be formed. So imine, when it is reaction with a lithium aluminum hydride, so imines, not reduction with lithium aluminum hydride, reduction with H2 in the presence of nickel. So here one hydrogen will be attached. Then CH3 bond, then CH2 bond, then NH2 will be formed. So what is this? amine. Which amine it is? Primary amine will be formed. So from the nitriles, from the imines, not nitrile, from the imines, imines can be reduced by hydrogen in the presence of nickel, hydrogen in the presence of nickel or platinum or palladium to form amines, to form amines. So even ketoimine also, ketoimine, for example, CH3 bond, C double bond, CH3, then NH, ketimine we call, ketimine. Then what happens there? Look at, so lithium aluminum hydride, lithium aluminum hydride, then CH3, so not even lithium aluminum hydride, hydrogen in the presence of nickel also, then CH3, then CH3, then CH bond NH2, then amine will be formed, isopropyl amine will be formed. So these are the preparation methods for the preparation of amines following reactants: azide, oxime, isonitrile, imines. Clear all of you? Right. Now we have to discuss about the basicity of amines. Basicity of amines have to discuss. So that are generally we are calling the chemical properties of amines. Chemical properties of amines. Chemical properties of amines. Chemical properties of amines. So in that, basicity of amines we are discussing. First one, basicity of amines. Basicity of amines we are discussing. This is very important topic. Very important topic. Basicity of amines. So generally for the acidic nature, if you want to find out the acidic nature, a particular substance we have to react with a sodium or sodium hydroxide or sodium hydride or sodamide or sodium bicarbonate, like this. But here amines, to identify the amines basic character, we have to react with acids. Once when it is react with acids, any salt formation takes place, then we can consider it is a base. So here generally before going to the reactions, sir, amine R bond NH2, R bond NH2, due to the presence of lone pair of electrons, due to the presence of lone pair of electrons, lone pair of electrons, this is act as Lewis base. Lewis base. This is act as Lewis base. And also we call nucleophile. Nucleophile because of electron rich. Then one more point you have to remember. R bond NH2 by taking of protons can form R bond NH3 plus. So if you observe this reaction, it is taking protons. Protons acceptor. It is working as a proton acceptor. Due to proton acceptance ability, it is also called Bronsted Brownsted base. Brownsted base. So amines, they are act as a Lewis bases as well as Brownsted bases also. Why Lewis bases? Because of presence of lone pair of electrons. Lone pair donor is called as then Lewis base. Here why it is called Brownsted base? Because H plus accepting proton acceptor is called as Brownsted base. Okay, clear all of you? Then, sir, one more important point in this, basic character when it is comparative with ammonia, then amines basic character is more. Why? What is the reason basic character is more? Then when it is compared with the other alkyl amines, so basicity of amines we have to discuss. Basicity of amines. Basicity of amines, it is depends upon the three factors. One is inductive effect. Inductive effect. So what is the inductive effect? What is the inductive effect group? Inductive effect, how it is working on the basicity of amines. For example, R bond NH2 is there. Here only one alkyl group is present. That is positive inductive effect is present. Then secondary amine if you take, here two positive inductive effect groups are there, plus I. Then tertiary amines if you take, three positive inductive effect groups are there. Recording. That's it. So positive effect groups are there. This is the tertiary amine. This is primary amine. Observe it carefully. Once alkyl groups are increases, alkyl groups generally act as electron donating groups. Sir, basic character also in the amines, R bond NH2 if you take, the lone pair electron should be donate. Lone pair electron should be donate to lone pair acceptor. Any electron deficient molecule. When it is donate, that we call it as a basic character. It contains a basic character according to Lewis acid base theory. Right. Once electron donating groups are increases, easily donate, right? So even here also lone pair of electrons are there. So due to increasing the positive inductive effect, basicity also increases. What increases? Basicity increases. Positive inductive groups increases. Basicity also increases. That is first reason. Second effect, salvation effect or hydrogen bonding effect. Hydrogen bonding effect. Look at, first I am taking R bond NH3 plus. Primary amine only, but it is taking one of the hydrogen atom from the water. So when it is mixed with water, then R bond NH3, H, then H, then H, like this. These hydrogens can form hydrogen bonds with water. Like this. Then here, sir, secondary amine if you take, NH, then bond NH, NH, secondary amine, one more alkyl group is there, H, then it can form only two hydrogen bondings. Then tertiary amine if you take, tertiary amine if you take, tertiary amine, it can form only one hydrogen bonding with, only one hydrogen bonding with water. Sir, observe, salvation or solubility increases, solubility increases, solubility increases, basicity decreases, solubility increases. Sir, here what I told, plus I effect groups increases, basicity also increases. So tertiary amines are more basic than secondary than primary. Sir, if you come to there, solubility increases, solubility increases, nothing but hydrogen bonds increases, then basicity increases, I told. Sir, here plus I effect groups increases, basicity increases. Here hydrogen bondings increases, basicity increases. So that, sir, here primary is more basic than that of secondary, than that of tertiary. What reason I told this character? What reason I told this character? Why? What reason I told this character? Because in the solvation effect, solubility increases, solubility increases, basicity also increases, basicity also increases, basicity also increases. Yes, yes, my dear students. Then third effect is there. Third effect, that is steric hindrance, steric hindrance, steric hindrance, steric hindrance increases, steric hindrance increases, steric hindrance increases. Right, look at. So steric hindrance increases, basicity decreases, basicity decreases. So what happens? Then primary amines are more basic than that of secondary amines, than that of tertiary amines in this factor. Why? Sir, in the tertiary amines, alkyl groups are increases. Once alkyl groups are increases, steric hindrance increases. So that steric hindrance increases, basicity decreases. Sir, actually in the aqueous solution of amines, basic character decide, one is solvation effect, one is steric hindrance effect. So based on these two factors, that solvation effect as well as inductive effect, based on these two factors if you take, then in case if you take R group is C2H5 group, C2H5 group, that is ethyl group, ethyl group if you take, then secondary amine C2H5 taken twice, NH is more basic than that of C2H5 taken thrice, N. Then next one C2H5 NH2, NH2. Then in case second one methyl group, with the first one, the methyl group in case if you take CH3, then CH3 taken twice, NH, NH. Then after CH3 NH2, primary. Why primary? Because it is not steric hindrance more. Because not it is steric hindrance more. So that's what it will come in front. Then after, then CH3, CH3, then NH2. CH3 taken thrice, NH, N. tertiary amines, sorry, tertiary amines. So in case if you take ethyl, secondary is greater than after tertiary, then after primary. In case methyl group, if you take, secondary is greater than primary, than tertiary, then after tertiary. So this is okay. Thank you.